To talk today about solving two-step equations. Well, not just two-step, multi-step equations. And what that means is there are multiple terms in our equation that have to be handled before we can isolate our variable. So when we're talking about solving equations, our whole goal is always to isolate our variable on one side of the equation. It doesn't matter if it's isolated on the left or on the right. The whole point is to get the variable by itself and to make sure it's positive. How we isolate the variable depends on the equation that we're presented with. I'm going to show you three different equations. Each equation is a little bit different, and there are different steps that you can perform to get the variable by itself and to ultimately isolate the variable and solve the variable. So I have three equations, one in red, one in green, and one in blue. Each equation's a little bit different, and they're all solved using the same basic steps, but just in different orders. What we want to do to isolate the variable is we want to remove whatever is being distributed on the side of the equation where the variable is. Sometimes we distribute based on a denominator. Sometimes we'll distribute with a number outside of parentheses. We also want to remove whatever term is not attached to the variable. And I mean, we want to remove the terms that involve addition and subtraction, where their variable is not involved in that term itself. We then want to remove the coefficient from the variable. Coefficients can be in the form of a whole number or in the form of a fraction. So take our red problem, 3x plus 14 equals 29. We're going to think about the three things that we have to do. Remove anything that's being distributed, remove anything that's not attached to the variable, remove the coefficient. Well, I don't have anything that's being distributed to the left side of the problem. I do have a term that is not attached to the variable. I have plus 14. And plus 14 can be removed from the equation, or can be removed from the left side of the equation by using the opposite operation. And the opposite operation of addition is subtraction. So if I subtract 14 from both sides of the equation, I'm going to zero 14 out from the left side. And I'm going to include 14 or minus 14 on the right side of the problem. And when I do that, I simplify both sides and I end up with 3x equals 15. Well, now I have to take care of the last step, remove the coefficient. So the coefficient for this problem is 3. I'm going to remove it by division because coefficients are basically multiplication between a number and a variable. Or in other cases, I could be multiplying two variables together. So I divide both sides of the equation by 3. These 3's, they don't zero out. They divide. 3 divided by 3 equals 1. So now my coefficient to x is 1. And I'm left with the equation x equals 5, which is also the solution to this problem. Let's look at the green equation next. So with the green equation, I have a number that is not attached to the variable, my minus 2. I don't really have a coefficient because there is nothing in front of that m, but I have something being distributed in the equation. I can rewrite this problem and take this denominator and pull it out and rewrite my problem this way. This means the same thing, okay? So I can take this 5, this denominator, and pull it out and treat it as a coefficient. And the way to get rid of a coefficient is to divide by the coefficient. So divide by 1/5. If I divide both sides by 1/5, these cancel out, and I'm left with m minus 2 equals, well, when I divide with a fraction, I have to do keep, change, flip. And 3 times 5 is 15. So I'm left with m minus 2 equals 15. Well, now I have to think back. I have to get rid of the term that's not attached to my variable, the minus 2. And to get rid of that, I'm going to add 2 to both sides. And I'm left with m equals 17. Our blue problem. Here we have something that's being distributed, that 3 as a denominator. I have a coefficient of 4, and I have a term that's not attached to the variable. I have that minus 5. So there's 3 things that I have to do to get the e all by itself. So the first thing I'm going to do is take care of that 3. I'm going to remove what's being distributed to the left side of the equation. And since that 3 right now is a fraction, it's showing division. So I'm going to multiply the whole equation by 3. And by doing that, the 3's on the left cancel out. And I am left with 4e minus 5 equals 39. So now I have to reevaluate my equation. I still have a coefficient that's attached to my variable. And I have that minus 5. So I'm going to take care of getting rid of that 5 first. And to get rid of a minus 5, I'm going to do the opposite operation. And I'm going to add 5 to both sides. The 5's on the left zero out. And I'm left with 4e equals 44. So all I'm left with now is my coefficient. Coefficients represent multiplication. And to undo multiplication, I need the opposite operation, which is division. So when I divide by a positive 4, 4 divided by 4 is 1. So now my coefficient is a 1. And my equation simply is e equals 11. So those are 3 different equations that we looked at. My steps are basically the same process. Remove whatever is being distributed, remove whatever is being added or subtracted to that side of the equation, and then get rid of coefficients. The order is the only thing that changes.